Dot skill presents volume calculation. Recall that a prism is a three-dimensional shape with polygons at two ends connected by rectangles. As long as the polygons are identical, they can be triangles, squares, rectangles, pentagons, so pretty much anything would work. So we are going to have a generalized formula for the area of the polygon and say that, okay, whatever polygon we have at the two ends, let's say the area of the polygon is A, and let's also say that the height of the prism is H. This could also be the length of the prism, depends on the way you look at it. I'm going to call it H for the height. And the volume of the prism is given as the area of the base multiplied with the height. So let's have that as a prism. A cylinder is a special type of a prism in which the polygon is actually a circle. So you have two identical circles in place of the two identical polygons. Well, you could think of a circle as a polygon again, a polygon with infinite number of straight edges. But the point is, at the end of the day, a cylinder is also a prism. So the same volume formula would work for a cylinder, and we could say the volume of a cylinder is equal to the area of the base, and the base is a circle in this case, and a circle is defined by its radius. So let's say the radius of the base is R and the height of the cylinder is H, and therefore the volume is going to be the area of the base, area of this circle, pi times R square multiplied with the height. And in the same way, we could have a rectangular prism that pretty much looks like this. Let me write down the name. It's called a rectangular prism. And let's say the length of this prism is L, the width is W, and the height is H. The volume of the prism is going to be equal to the area of the base. The area of the base is L times W multiplied with the height, and that's H. So you pretty much multiply the three dimensions to get the volume of a rectangular prism. And a rectangular prism with different lengths, widths and heights is also referred to as a cuboid. A cube is a special type of a rectangular prism in which the length and the width and the height, they're all the same. Which means you have squares on all sides. And like I said, the length, the width and the height, they are all the same. Let me name them as L. So the volume of a cube is given as L times L times L, which is equal to L raised to the third power, or L cubed. Recall that a pyramid is a three-dimensional shape with a polygon base and triangular faces that meet at a point at the top called the apex. The perpendicular distance of the apex from the base of the pyramid, the polygon, is called the height of the pyramid. Let me write down the name first. So we are talking about pyramids. And let's say the area of this base is A. Let's keep it general. So the base could be a square or a rectangle or a triangle or any polygon shape. The area of the base being A. The volume of the pyramid is always given as 1/3 times the area of the base times the height. Or in other words, it's 1/3 the volume of the corresponding prism. By corresponding, I mean if you have the same polygon on a prism, on both sides obviously, a prism doesn't have an apex, it's got the same polygon on two sides. So imagine having a prism with the same exact polygon on two sides and the same height of the prism, the volume would be A times H. And the volume of the pyramid on that same base and that same height is exactly 1/3 the volume of the corresponding prism. And a special type of a pyramid is the cone, in which the base is a circle. So just as the cylinder is a special type of a prism, the cone is a special type of a pyramid with a circular base. The circle has got a radius and the cone has got a height, which is the perpendicular distance of the apex from the center of the circle. And this angle out here is actually a 90 degrees or a right angle. Let's say the radius of the circle is R and the height of the cone is H. And the volume of the cone is equal to 1/3 the volume of the corresponding prism. Now what is the corresponding prism for a cone? And the answer to that question is a cylinder, because imagine having this circle on both ends, you get a cylinder, right? And we know that the volume of a cylinder is given by the formula pi r squared times h, where r is the radius of the circle and h is the height of the cylinder. So the volume of the cone is going to be 1/3 times pi r squared h. And finally, let's talk about the volume of a sphere. Let me write down the name to distinguish it from a circle. The volume of a sphere is given by 4/3 times pi times r cubed, where r is the radius of the sphere. Every sphere has a radius, right? It's like a three-dimensional circle. Let's try a couple of problems now. Find the volume of a rectangular prism with length is equal to 8 centimeters, width is equal to 5 centimeters, and height is equal to 2 centimeters. So we have a rectangular prism. And not necessarily drawn to scale. And I hope that doesn't matter as long as we do the problem right. So we have a 8 centimeters, a 5 centimeters, and a 2 centimeters. These two sides have different numbers on them, but they look to be the same size. Reason why I said I have not been able to draw this picture to scale. And that doesn't count as long as you know how to find the volume of a rectangular prism by multiplying its length and width and height, which is equal to 8 times 5 times 2. 8 times 5 is 40, 40 times 2 is 80. So we have 80 centimeter cube or cubic centimeter as the volume. Let's try another one. Find the volume of a cone with height is equal to 12 centimeters and slant height is equal to 13 centimeters. So we have a cone and it's given that the height of the cone is 12 centimeters and the slant height, which is this one, is equal to 13 centimeters. Now if you think about the formula for the volume of a cone, volume is equal to 1/3 times pi r squared h, where r is the radius of the circular base. and we do not know what the radius is. It's not given. We do not need the slant height in the volume calculation, but that has been given. So what do we do? To find out what the radius of the cone is, or what the radius of the circular base of the cone is, we complete the triangle that has got a right angle in it over here and go on to apply the Pythagorean theorem. So if we name this radius as r, we have the square of the hypotenuse, which is 13, the slant height given, is equal to the sum of the squares of the other two sides. 13 square is 169, is equal to 12 square, or 12 times 12 is 144 plus r square. If you take the 144 to the other side, meaning subtract 144 from both sides of the equation, you have 25 is equal to r square, or r square is 25, which means we got the radius, that's 5 centimeters. So there we go. The volume is 1/3 times pi. Pi is a constant, that's 3.14. Let's keep that as pi. Multiplied with r square, r is 5, therefore r square is 25. So we have pi times 25 times 1/3 times the height, which is 12. And that simplifies to the cross of the 3, cross of the 12, you have a 4 here. We have a neat 100 pi cubic centimeter, or centimeter cube.